In this video, I will introduce to you the concept of a correlation coefficient and how to calculate and interpret its value. As previously mentioned, a scatter plot is a useful diagram that can be used to observe the presence and the type of correlation. Observe in these 5 scatter plots. 1, 2, 3, 4, and 5. The thing that they all have in common is that there is a positive relationship between the independent variable and the dependent variable. However, the strength of the relationship in each case is different. In this plot here, the values are greatly clustered, which indicates that the positive correlation or the positive relationship is very strong as compared to this plot here where the values are more dispersed, which indicates that the correlation is weak despite being positive. So on a scatter plot, we're able to qualitatively describe the strength of the relationship based on how clustered the values are. It becomes useful then when we're able to quantify this relationship, since to the untrained eyes, two plots may appear to be very similar, and you may want to conclude that the strength is the same when in fact it is not. And that is when a correlation coefficient becomes convenient. Correlation coefficients are used in statistics to measure the strength of the relationship between two variables. There are many different correlation coefficients, and the one covered in this course is the Pearson's product moment correlation coefficient. Pearson's product moment correlation coefficient, which is denoted by the common R. Now this common R represents the sample correlation coefficient, and the Greek letter rho represents the population correlation coefficient. The Pearson's correlation coefficient R is a value between -1 and +1. So R is between -1 and +1. And then we have the less than or equal to sign, which indicates that -1 and +1 are also inclusive of the value that R can take on. This table here summarizes the correlation coefficient scale. That is the interpretation of the calculated correlation coefficient. Observe that as the values get further apart, the correlation coefficient gets smaller. And this applies to both sides of this table. As the values get further apart, the correlation coefficient gets smaller. Over on this side, it is clear that the variables are positively related as the values follow an upward sloping line. And over on this side, the variables are negatively related as the values follow a downward sloping line. Also note in the specific case where the correlation coefficient is equal to 0, that is an indication of no correlation. Also note that there are other scales that can be used. Here is another, and it shows basically the same thing as the previous. These scatter plots were introduced earlier, and here are the respective correlation coefficient for each plot. The idea that you should walk away with is that as the values become more clustered, the correlation coefficient gets closer to 1 or -1, depending on whether the relationship is positive or negative. And as the values become more dispersed, that is, they move in this direction now, the correlation coefficient gets closer to 0. This is the formula used to calculate the Pearson's product moment correlation coefficient. Now, at first glance, it appears to be the girlfriend from hell, but upon closer inspection, it is actually very simple to calculate. Let's examine the formula a bit closer, and I will use an example to demonstrate. Let's say the independent variable x takes on values 0, 1, 2, and the dependent variable y takes on values 1, 2, 3. In the formula for the correlation coefficient, n represents the number of pairs of values. So this is 1 pair, 2 pairs, 3 pairs. So n equals 3. This other summary statistic, so each one of these is called a summary statistic, and for the purpose of this course, you're required to use summary statistics to calculate the correlation coefficient. So this summary statistic here is read as the sum of the product of x and y. And what we do to get this value, we need to multiply each x value with its corresponding y value and then add those products together. So the sum of x, y equals 0 multiplied by 1 plus 1 multiplied by 2 plus 2 multiplied by 3 equal, so 0 multiplied by 1 is 0 plus 1 multiplied by 2 is 2 plus 2 multiplied by 3 is 6. So the sum of xy equals 8. The second part, or the other summary statistics, says the product of the sum of x and the sum of y. And to calculate these summary statistics, we need to add all the x values together. That's how we get sum of x. Then add all the y values together. That's how we get the sum of y. And then we multiply the sum of x and the sum of y. So the sum of x equals 0 plus 1 plus 2 equals 3. And the sum of y equals 1 plus 2 plus 3 equals 6. This summary statistic is read as the sum of x squared. And to calculate the sum of x squared, we take each x value, square it, and then add them together. So it's 0 squared plus 1 squared plus 2 squared equals 0 plus 1 plus 4 equals 5. To find the sum of x all squared, we take the sum of x, which we already found to be 3, and then we square it. So the sum of x squared equals 3 squared equals 9. Next is the sum of y squared. And just as we found the sum of x squared, we take each y value, square it, and then add them together. So 1 squared plus 2 squared plus 3 squared equals 1 plus 4 plus 9 equals 14. And to find the sum of y all squared, we already have what the sum of y is. So we just square that value. Sum of y all squared equals 6 squared equals 36. And so now we have the value for each of our summary statistic, and all that's left to do is to substitute these values into the formula, and we would be able to calculate the value of the correlation coefficient. As an exercise to test your understanding, calculate and interpret the correlation coefficient for this hypothetical data set and for the other two that follow. You can write your answers in a book or post them to our Facebook group.